Yes, we welcome you back to PSSB with me, Richard, here. Yeah, today we are looking at this question. It says, identify the suitable indicator for each of the following titrations. Okay, they say, write phenolphthalein indicator, methyl orange, or bromothiamine blue. Okay, the first one says strong acid plus a strong base. Okay, this medium is going to become what? A strong acid and a strong base produces a neutral medium. It's neither acidic nor basic. So which indicator works best in the neutral medium? The indicator is bromothiamine blue. Okay. Then comes this one, weak acid plus a strong base. Okay. A weak acid and a strong base, the medium becomes what? Okay, you need to know that it's the strong which takes the pH. So in other words, base being stronger, we are going to have the medium as basic or alkaline in nature. Okay, if that's true, then which indicator works well in basic? That is phenolphthalein. So it's phenolphthalein indicator. Okay. Then we come to this one, strong acid plus weak base. Like I said before, it's the strong which takes the medium. So acid is strong, the medium is going to be acidic. Okay. And if it's acidic, which indicator works well in acidic medium? It is methyl orange. Okay. Then comes this question. It says that calculate the pH of the solution made up of 0.2 grams of hydrochloric acid dissolved in 2.2 cubic decimeter. Okay. Yes, how do you go about this? The question is looking for pH. Okay. Okay, how do you deal with that one? You have to remember this. You have to remember that pH is given as negative log hydronium ion concentration or hydrogen ion concentration. So concentration means moles per cubic decimeter. So what are we going to do here? What we are going to do is that we are going to find the concentration of hydrochloric acid. So what do we have? Let us check what we have. You have the mass of hydrochloric acid, which is 0.2 grams. Okay. You know the volume. The volume of hydrochloric acid of this solution is 2.2 cubic decimeter. You don't have to convert. It's already in SI units. Okay. Then what are we calculating? We are going to calculate C. Okay. So with this information, you have to quote the formula which relates information and mass. And the formula says C is equal to mass over molar mass times volume. Now the formula shows you that you are missing molar mass. Molar mass of what? Of hydrochloric hydrochloric acid or hydrogen chloride. So you say molar mass, HCl. Okay? Where H is 1 and Cl is 35.5, giving you what? 36.5. With that information, we can now substitute. We can say, okay, do we know mass? Yes, it is 0.2. Do you know molar mass? Yes, it is 36.5. Do you know volume? Yes, it's 2.2. So from here, we go ahead and find the concentration. So this is what we get. The concentration of hydrochloric acid is 0.00249 moles per cubic decimeter. So what is the next step? Next step actually is to look at how hydrochloric acid ionize. So this is what we know. We know it is HCl, aqueous. So it ionizes to give you hydrogen ions, which are aqueous, plus chloride ions, which are aqueous. Or if you are experienced and strong enough, you can use water and say HCl plus water. It is the acid, so donating a proton gives you hydronium ion. Plus what? After donating a proton, we remain with the chloride ion. So that is it. Both this equation release one information. What is it? That 1 mole of what? Of hydrochloric acid release 1 mole of hydronium ion. So mole ratio is 1:1. What does that mean? That if you have 0.00249 moles per cubic decimeter as HCl, it will be the same it will be the same concentration here, because mole ratio is 1:1. So now we are armed with what? The concentration of hydronium ion. So we can go ahead and substitute. What's the equation? We said pH is equal to negative log hydronium ion concentration. Okay? So which is going to be negative log 0.00249. So giving you what? So giving you 2.6. So the pH of the solution is 2.6. Yeah. Then comes this question. It says, calculate the pH of sulfuric acid of concentration 3 grams per cubic decimeter. How do we go about that? Okay, here you have to know that if it's pH, then it is going to be negative log hydronium or hydrogen ion concentration, either way. So that's the formula we have. So our task is to calculate the concentration of hydronium ion concentration. Okay, how do you go about that one? This is what you have to know. That for sulfuric acid, we know the concentration, but it's in grams per cubic decimeter. And our concentration here is supposed to be in moles per cubic decimeter. So let's check what we have. You have the mass. Okay, the mass is 3 grams. You have the volume, and the volume is 1 cubic decimeter, because it is 3 grams dissolved in 1 cubic decimeter. So what are we looking for? We are looking for concentration. Okay. So here you have to quote the formula which links concentration to mass. And the formula says C is equal to M over mv. The formula shows that you are missing something important, which is the molar mass of sulfuric acid. So you have it here. It's the molar mass of sulfuric acid, okay, which is going to be 2 for hydrogen plus 32 plus what? 16 for oxygen times 4, giving you, the molar mass for sulfuric acid is 98. So now we can go ahead and substitute. Okay. So what I'm going to say, the mass is known and it is 3 grams. Okay. Our molar mass is 98. And times what? The volume. And the volume is 1. So what you get here is going to be the concentration in moles per cubic decimeter. So that is that. And the units are moles per cubic decimeter. So it is 0.0306 moles per cubic decimeter as the concentration of our acid. Okay. So how do you proceed from here? Okay, you go ahead and look at how sulfuric acid ionizes. So we are having it like this. It's going to be sulfuric acid. Okay, you can say aqueous, means dissolved in water. So on ionization, what do you get? You get 2 hydrogen ions aqueous plus sulfate ions. This way out helps you to escape use of water, which most people find it a bit harder. But you can also go to water. But I would urge you that when you're dealing with sulfuric acid in examination, just don't involve water, just use this. You have to know that hydrogen ions in aqueous solution, they are the same as hydronium ions. So when you are at this level, what do you do? Okay, let me also show you how it would be with water, but I will be using that one. With water, we are going to have sulfuric acid plus water, giving you, okay, so the acid donating there, we get hydronium ion plus sulfate ions. You balance by putting a 2 here. When you put a 2 here, this becomes 6. So it means that you have to put a 2 here. And we are going to have the same mole ratio. 1 mole of sulfuric acid releases 2 moles of hydronium ions. Sorry. It is 2 moles of hydronium ions. So the same applies here. What do we get from here? We get 1 mole of sulfuric acid releasing what? 2 moles of hydronium ion. So what do you do here? You quote these. These ones are the number of moles of sulfuric acid. So you put them here. They are going to be 0.0306 number of moles per cubic decimeter, which is concentration. But the mole is 1 to 2. So what are you going to have here? X. And how do you find X? Through cross multiplying. So you are going to say X is equal to 0.0306 times 2. Yeah, so this is what you get. You get this, but it is concentration, implying what? That it is in moles per cubic decimeter. So we have this one. What does this represent? We all know that it represents that, what is it? The hydrogen ions or hydronium ions. That is very important because it is the hydronium ions which we substitute We don't substitute the acid. So what do we get here? From there, you can proceed and say pH equals to negative log hydronium ion concentration. So what are we going to get here? Negative log 0.0612, giving us what? Giving us this as the pH of the medium, 1.21. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like. And we also remind you that this channel specializes in physical sciences grade 12, 11 and 10, and natural sciences grade 8 and 9. We urge you to make use of our playlist, very enriched playlist. So just go to playlist and click the material which belongs to your level. For grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. For grade 12, each chapter is presented independently. Just look for the chapter of your choice and you'll have all the material which belongs to that chapter. With that, I would like to say thank you. We love you. See you next time. Bye-bye.